During manufacturing, it's important that we always use safety in the lab. We always made sure we're wearing our PPE, which included goggles or glasses. If your hair was below shoulder length, we had it tied back, and we always wore closed-toed shoes and made sure that we had a manufacturing buddy. During the welding process, we made sure that we wore a coat, gloves, and a welding mask. When we cut the fiberglass seat, we made sure that it was under a ventilation hood and we had a mask on as well. And while working with chemicals, we wore rubber gloves.
Lights, reflectors, and mirrors, and bells will all be added to the vehicle prior to competition.
Additional safety features, we've added a chain guard which protects the rider from the crank as well as the chain. We've also enhanced safety by adding padding and foam to the seat. And we will also be adding a kickstand to keep bystanders and the rider safer while the vehicle is not moving.
On our actual bicycle, we have a 4-point harness installed as per regulations of the competition. In addition, we have our roll protection system, which goes above the head of our rider. We also have designed so there are no sharp corners on the inside of our design. And in addition, we will be placing padding on the inside of the roll bars to ensure rider comfort. As far as the rest of the bike goes, we are planning on putting a chain guard on our chain, and those are our safety features. We have these brake cords that will be fastened to the side of the bike to prevent the rider from hitting them while riding, and that will kind of be solved when our steering is completely finished.
All right, so yesterday we had a fully assembled bike. However, when we went to perform our rider trials this morning, we discovered that there were serious issues with the design. So number one, we deviated from the design presented in the competition report in that we no longer had a cable and lever system for steering. Instead, we implemented a steering column that went to a steering wheel and had a double U-joint to translate the rotation to the front fork. However, when we made this alteration, what we didn't realize was that the friction that was provided by the collar of the steering column and also the slop in the double U-joint prevented the bike from leaning into turns. And consequently, when we went to perform our rider logs, we found out that the bike would tip whenever we tried to turn. This was also exacerbated by the fact that when we got the seat, we found out that it has ridges on the back that wouldn't allow us to mount it as low as we would have liked. So consequently, we immediately began disassembling the bike to fix these errors. The alterations we are going to make, number one, is we have removed the back bar that the seat sits against, and we're going to mount it lower. In addition, we're going to do this to this lower bar as well so that we can lower the rider's center of gravity. But we are also going to remove the steering column and change the steering system back to one that allows the bike to lean into turns and give us our stability back. Before we had to disassemble the bike, we had fully functioning brakes on both wheels. We had no problems there. We had no problems getting the bike up to speed. It was fully able to make the 8-meter turn radius. However, we couldn't, there was only someone was holding it. But we're confident that once we make these changes, we will be able to meet all the safety requirements, and we will be able to have our rider logs by the time that we have mentioned in our email to you.